Dear engineers, in this lecture, we're going to learn about how we can finally design a beam, and also how we can make a detailing on it professionally, because this is a professional building. Already I have designed, analyzed, I have completed everything as per our code. So if you want to know about design of that design process of that software, if you want to know about Etabs professionally, then please visit to our website, that link given in our first comment and description. And also document used here, if you need that, also you can visit our website, that link also given in first comment and our website. So first of all, we have to create some group. Now I'll click here. I'll just first go here, design, display design. Okay, now here we're seeing that all of our beam are failing for overstress, and I checked that why it's failing, so we'll solve it later. Now here we have to create group on it. So why we need grouping? It's important that why we need grouping. As a engineer, we have to design most economically. Okay, so here we're in study 1, and if I just go to bottom, then here for our grade beam, this is base, this is for grade beam. So in ground floor, we'll design that later. First of all, I'll just go for our ST1. Now always remember that how much time I have found that in Etabs or in any design process, bottom story or story in bottom shows maximum reinforcement than top story. So if you want to design as a typical section, or if you design as a typical beam floor, then you can consider story 1, first story, and then suppose here we need reinforcement for 1.3749. okay, and now if I just go in top, just see reinforcement are decreasing. If I go to top, reinforcement are decreasing from every section, because every effect on our top story are less than bottom. So what we'll do now? Okay, what we'll do now? We'll go for designing fast story, because if you have capability to design for each story different, you can go for that, or you can create detailing on it. But in our country, it will be very difficult for our worker. So, and also sometime when engineer are not in the site, then we'll go for that section. So what I'll do, I'll just first of all I'll create grouping for two types of section, like where our torsion reinforcement are required or where our torsion reinforcement are not required. So I'll click here. You can see here only our beam section here are torsion reinforcement are required, and if I just go to the top, almost maximum section no need any torsional reinforcement. Clear? Except our bed beam, a beam below or beam around our staircase. So without that 4 beam will create on group, and for that 4 beam will create on group, and this one will be different. Here it will be different, so I'll go here yesterday 1 and go for longitudinal reinforcement. Now we have to find out where we need maximum reinforcement. Okay, let's add our slab. So that we can also that null line. Okay, so here our beam, let's see, as we're seeing here, we need 1.3749 inches square reinforcement. Here also need 1.04 inch reinforcement. Here I need 1.2, 0.7, 0.86. What I can do here, we need 1.42 to 1.47, as its length are very high. That's why reinforcement requirement is also very high. So just saying, if I provide that reinforcement 1.42 inches square reinforcement also here, then it will be almost double. And also see, for that beam it's required 0.86 maximum, 0.57 maximum, 0.7777 maximum. So for that beam also, if we provide reinforcement for that beam, so I think it will be more and more uneconomical. So what I can do, that I'll create two group of that beam, So how? For that beam, on group, that on, also that on, and so for this and this, for this beam we'll create on group, and for another that line, and also for that line and that line we'll create another group. Okay, let's start. So first of all, I will show you about on group. First of all, I'll go for that section here, or just let's take a pen. Yeah, that one. Okay, so okay, skip also that one. Here on need 1.16. So what I can do now, I'll skip that one also. Okay, so here first of all I will open out that Excel design parameter, Excel fxl8. You will get that Excel file in our website, link given in description. Simply this is our bottom side here. Now what I'll do, I'll provide that required reinforcement here. So I'll see how much maximum reinforcement we need actually. 0.94 in top section, maximum reinforcement, how much maximum reinforcement required. So we can see that for that 4 beam we need 0.94. 0.94, and here also 0.94. sorry, 0.94. Actually, for that portion and for that portion, we have to provide reinforcement for that portion and that portion, but we'll take maximum of them. Clear? Now I'll go for middle of bottom middle. So 4 on 2 6 3 6. So I'll take suppose 4 on 0.42. On you have to provide value on yellow box, not on red box or that color. So for top middle 0.29 24 23 36 0.3 0.29, and for left side and right side of bottom 42 44 49 49 or 0.5 is maximum. 0.5 0.5. Are you clear about that how it's working actually? Okay, now if we have any torsional reinforcement here, suppose if I show you torsion reinforcement apply, see only the beam we have selected here have no torsion, but if we have torsion here, then what will do actually? What will do? If we have torsion, then what will do? Suppose here we have torsion. Always remember torsion in top for transverse reinforcement and torsion in bottom for longitudinal reinforcement. Always remember that. Okay, don't mistake here. So suppose if we have that reinforcement 0.348 on 0.34, now we will make that reinforcement, I will divide that reinforcement in 3 parts. Okay, for torsional reinforcement. So let's 35 divided by 3. So this is the reinforcement 0.1 on 6. I'll take 0.12. So that reinforcement, if we have a beam, say here we have a beam, so in top, with top reinforcement we'll add that, with bottom reinforcement we'll add that, and this part also will go for that or side reinforcement as a side reinforcement at middle. Okay, at middle portion we'll provide here. Okay, so this is the total required reinforcement of that portion at middle portion, 0.1 on. So it's enough. Also we divided that value 1 on that value will divide by 2. Suppose say 0.12 divided by 2. So we need 0.12 divided by 2. 0.06 inches का reinforcement we need for that side, for that portion and also for that portion. Is it clear? So first of all we'll divide our torsional reinforcement in 3 parts, and one of them will go to top, we'll go with top reinforcement, go with bottom reinforcement, and another part will be divided by 2 again, and we'll provide here and here as per ACI code or ACI recommendation. Is it clear? So as we have no torsional reinforcement here, we are not going to add that, and if we use that Excel sheet, if you use my Excel sheet, it will give you that extra facility to complete it. So here suppose if this reinforcement this value is required, Then what we'll do, we'll just add it here. 0. How much was that value? 35. If we add that torsion value here, in every box it will be added automatically. Our previous value was 0.94. Then with that value, this is the reinforcement for top river, and this is the reinforcement for bottom side, left side of our top, middle of our top, and right side of our top. Okay, now what I can do here, just see, the final reinforcement we need for longitudinal reinforcement is here, and for bottom it's also here. Is it clear to you? But as we have no torsional reinforcement, so we can make it 0. This is the way of our detailing. We'll go to AutoCAD for final drafting. Now we have to check another thing. As per code, we need in the above version, the version, if you use the latest version of Etabs, then it will give you automatically the minimum reinforcement. But in lower version, I'm using Etabs 16. Also we have tutorial on latest version. You can also watch that. So here I'll click here, minimum river calculation, and as per our code, ACI code, you can also do it. So to find out that, I need beam section first, 10 into 15 inch beam. So I'll just give here width 15 and 10 inch, and F prime C 3000 something psi, and Fy, yield strength of a reinforcement is here 500 MPa megapascal. So now what I'll do, actually just see here, as per ACI code, it's giving us the minimum reinforcement. If you need that formula, you can go to code. Now here, see, our value is 0.35 maximum. Here 0.35 maximum. Now I have to check that is it okay with our provided value or not. Just see here that all value is above 0. That value in yellow box actually are above 0.35, except that one, 0.23. So what I'll do, I'll provide a 0.35. That's it. Just we have to do that task. Clear? Now we'll go for our final detailing. And always remember another thing, in beam we cannot provide reinforcement less than 16 mm. Okay, so when everything is okay, we have learned about normal reinforcement, we have learned about our torsional reinforcement. Now we'll go for our next lecture or next session. This is shear reinforcement of our beam. So for shear reinforcement, we have to use another Excel sheet. You will find that Excel sheet in our website as a paid resources. So here that one will be E1 series. In E1 series you will find that. I just click here. Also you can do it as per your code, no problem. So I will complete that as a ACI code. See here, as a ACI code, I'm going to find out that. Now width of beam, depth of beam is 15 inch. Frame type, so as previous we have discussed, our frame type is a special moment resisting frame. Fy, this is the Fy. Effective covering, so effective covering, normally what is effective covering actually? Let's discuss about that. Effective covering means when we have a reinforcement here, long reinforcement. Clear cover means covering after our is stirred up, but for effective covering are from center to clear phase of clear face of our concrete to center of our long reinforcement. Is it clear? So it's normally in our country we provide 1.5 inch as a clear cover, and with and if we calculate that, it's also, suppose how we calculate it. Here we have a stirrup. First of all, 1.5 inch clear cover, then size of stirrup. So if we provide 10 mm stirrup, then it will be 10 divided by 25. If we divide with 25, that it will be inch 10 mm. Then half of that long reinforcement. So if we provide 16 mm reinforcement, it will be 16 divided by 25. As I'm writing with mouse, that's I'm facing problem. 16 mm divided by 25.4 actually, so let's ignore it, into 2. Why 2? Because half of 16. Clear? And if we calculate that value, it will be almost that value. Okay, now leg number means, suppose this is a stirrup, this is the stirrup, and if we cut here, we'll see here one and here one portion of our tie, such of our stirrup. So it's called as two leg stirrup. So you can search on Google for leg of stirrup for details. 2 and required shear bar. So what is the required shear bar? We'll go to software, and from here I'll just go here shear reinforcing, then apply. We can see here our maximum, we'll find out maximum from that beam 0.30, 0.37, I think 0.3674. It's 37 is maximum. So I'll just go here, let's take it 0.4, no problem. Then die of shear bar 16 and die of smallest long bar. So what will be the smallest long bar? Will provide 16 mm as a smallest long bar. So it's done. Now you can see our left side it's 3 inch, our right side it's 3 inch as per code, and here it's 6.35. If you change it for intermediate, it's also same for beam, but for other system, see, it will give you that value. So I'll take a special moment resisting system. So here 3, 6.5 and 3. Is it clear? So now everything is okay. We'll go for our next step. Now we'll go to our AutoCAD for our next step. I'll just close it. Now we no need that Etabs file at this time. I'll save it and I'll close it, and I'll go to our AutoCAD. We'll open our final plan. That plan and detailing file are also given in our website, so you can take it as a name of beam detailing resources. In our previous lecture for our column detailing, we have done it. You can watch our video in that playlist, or you can go to playlist of our YouTube channel. Now here I will take our beam section. Here we have every default file for detailing, for quick detailing, and I have created that in our structural detailing course. So if you want to join, you can visit our website for professional learning. So now I need beam. So where is the beam section? This for here as well. This is for our beam. Okay, so I'll just copy that. copy it. I'll just go to or that section and I'll paste it here. Okay, so take its name as a floor beam 1. We'll provide that name as a floor beam 1, and first of all we have to change it 10, double click 10 and 15. Okay, also here 10 and 15. Remember that this value is with slab thickness. Okay, now let's change that value. Our shear reinforcement at section 1 means the left side and right side of the beam, and B means middle of the beam. So how was our that value? That value was 3 inch. Okay, 3 inch at left and right section, and here 6.25, so 6. Is it clear? Like here 3, 6.35 and 3. So we have provided 3, 6, 3. Is it clear? So we have provided shear reinforcement as per ACI code. Is it done? Now also, if you need that Excel sheet, you may visit our website. Now we'll go for our longitudinal reinforcement. So in longitudinal reinforcement, I'll just simply use that Excel sheet. Now we need what we'll do actually, in bottom we need 0.5, maximum 0.42. Always we'll try to cover with middle reinforcement, then we'll go in left side and right side, because in middle we need 0.42. so as we need 0.42, I'll just provide here 0.42. okay, and number 0, 16 mm beaver. If we provide 2 16 mm beaver, we are providing 0.62. that is maximum, that is 0.2. I mean we are providing more value than our 0.2 more value than our required value. So it's okay, because less than 16 mm we cannot use. Okay, or it's not should be okay, or it shouldn't be used actually. So 16 to it's done, 16 mm 2 bar, and if we provide that value 16 mm 2 bar, it will be okay, because it will cover our whole beam. Suppose now here we have 0.8, what will do actually, and here also 0.8 suppose. So as we have provided 42, overall we'll provide 42 here like that for our standard top bottom. Okay, we'll provide 2 nose 16 mm overall. Sorry, I have done a mistake, because normally here this value shouldn't be more than that value, or it will be very close to each other. But if it's have extra, then what will go, we'll provide that value also here, we'll provide that value also here. Why? Because here it's not recommended to use extra top in bottom also here. So in bottom we'll focus on maximum value of them. Okay, and if this value is more than, suppose this value is 0.8 and this value is 0.5, 0.5. So if we to provide 2 long reinforcement with 16 mm 2 bar, it will be covered 0.62. okay, and also we have to provide that value here, that value to 16 mm bar, and more extra reinforcement required. If we provide 3, so it will be 0.93, and here we need 0.8. This is also a required value. Okay, our provided value is also more than our required value, so it's okay. Then we'll provide a bottom extra top. I'll go here and I'll provide here 1. Clear to you? But at this situation, no need any extra top. I'll just close it from here. If you want to know how we have created that, how we'll detailing professionally, this course is also available to our website. You may visit there. Now I'll go for top. So at middle, in top, always you will see middle reinforcement is less than our left side and right side reinforcement. So what we'll do, we'll go here first. We'll provide 3. We'll provide 16 mm 2 bar. We'll provide randomly always in top and bottom. Nothing to do here. So if we provide 2 16 mm river in top, then our middle portion will be covered. So I'll go to our detailing, and for long reinforcement, I'll provide 2 16 mm river. And now for left side and right side, how much we need extra reinforcement? So if we provide here 3 reinforcement, then our value will be 0.9349. 0.9349. So this is a little bit less than our required value. So always remember, we cannot provide the less value here actually we needed. Okay, so what we'll do, I'll provide 2 16 mm as a long bar and on 20 mm. So our total value will be 1.11. It's okay, and we need 0.94, and this value is more than 0.17 times higher than our required value, so it's okay. So we'll provide, we just go to our AutoCAD, and here change it 20 mm extra bar, and here also 20 mm extra bar. Is it okay? So our section is okay. Now I'll just go here. What we'll do, our 216 mm plus 216 mm plus 120 mm. 120 mm. Clear? Our clear cover here given, and we no need sidebar because we have no torsional reinforcement. We no need sidebar. We no need here. And in bottom here, first of all, we need 2 reinforcement. 16 mm 2 reinforcement, 16 mm 2 reinforcement, and in top here we need section B. At middle we need 2 reinforcement, 16 mm 2 reinforcement. I'll just close it. See here, and the section B we have only one river, and it's 16 mm 2 overall, and we need to no need here, no need here. In bottom of that section also no need that reinforcement. Sorry. Okay, and 216 mm, 216 mm and 216 mm in section B. Here, see here and here, and here we need 1.2 120 mm and 216 mm. So this was our final detailing. I hope this session was this session is clear to you, and if you think that this is okay for you, then you may support us by joining our educational access for more valuable tutorial and more support. And also you can join our professional course on our website, or you can get the Excel file required professionally to work professionally in our this Excel file is also available to our website. So thank you very much. And if you need further learning, or if you need to know anything, then let us know. We'll create lectures on it. So thank you very much. Stay connected till next lecture.